Hello and welcome back to Chapter 2, Section 2.3. Today we're going to look at polynomial and synthetic division. In this section we're going to look at two different methods for dividing polynomials. The first one is going to deal with long division. The second method we'll look at is going to be synthetic division. And the reason we want to do some type of a division is because sometimes it's not always easy to factor or to identify the zeros of a function. So we may have to go ahead and do long division or synthetic division to help us find factors of a certain polynomial. So let's look at example 1, where we're going to divide 6x cubed minus 19x squared plus 16x minus 4 by x minus 3. So the first thing we're going to do is we're going to see how many times this value right here of x goes into our first term, which is 6x cubed. So x times what will give us 6x cubed? And the answer to that would be 6x squared. So if I take my x here and multiply it by 6x squared, I should get 6x cubed, which I do. So 6x cubed. Then what I'm going to do is I have to multiply this negative 3 by the term up here. So a negative 3 times a positive 6x squared is going to give me a negative 18x squared. And then I have a saying, we're going to hug it with parentheses and slap a negative on it. Now what we're going to have to do is we are going to have to distribute that negative onto both of these terms. So now when I put that negative on, really what I'm doing is I'm making it so I can add these terms together. So now if I add these, I have 6x cubed plus a negative 6x cubed, which is going to give me 0. Then I have a negative 19x squared plus 18x squared, which is going to give me a negative x squared. Then we have to pull this term down. So I have plus 16x. And because that step was so fun, I get to do all over again. Now I have a new equation. I need to see how many times this x right here will go into this term right here. So what times x will give me a negative x squared? And your answer should be a negative x. So if I take this term right here, multiply it by this term, I should end up with a negative x squared, which I do. Then I'm going to multiply this negative 3 by this x up here, or negative x, excuse me. So negative 3 times a negative x is going to give me plus 3x. I'm going to hug it with parentheses and slap a negative on it. I'm going to make that an addition and distribute that onto everything in here. Now I can add straight down. I have a negative x squared plus a positive x squared is going to give me 0x squared. Now I have 16x plus a negative 3x, which is going to give me 13x. I have another term to bring down, so now I'm going to go minus 4. And I have to start the whole process all over again one more time. So this x times what will give me this 13x? And the answer to that is a positive 13. X times 13 will give me 13x. Then I'm going to take this negative 3, multiply it by this 13. Negative 3 times 13 is going to give me a negative 39. Hug it with parentheses, slap a negative on it. We're going to distribute that negative, change that sign to a plus, and now I have a negative 13 and a positive 13 are going to give me 0. Negative 4 plus a positive 39 will give me a positive 35. I have no other terms to bring down, so it's just going to stay 35. X will not go into 35, so I'm done right here. Now, if you guys remember from doing long division way back when I have a term that's left over like this right here, this is really our remainder. Okay, and a remainder is just a fraction of something that's left over. So because this is positive, I'm going to come up here and I'm going to go plus. I have 35, and this 35 is really a fraction of this right here. So I'm going to put that in my denominator, so x minus 3. Now there's a few things I want to kind of call out here. Okay, if you remember from doing long division, this term out here that we're dividing by, this is called our divisor. And yes, it is important that you know the different pieces of a quotient or something that's being divided. Okay, this stuff underneath the division symbol, this is called our dividend. This is what's being divided. So our dividend. Okay, the answer to our division problem is called our quotient. And this little fractional piece, which is really coming from down here, this is called our remainder. If you have questions on this stuff, please let me know, but you are expected to know this. Now, if you recall, your function, which would be f of x, is going to equal your divisor, so I'm just going to say d of x, times your quotient, or q of x, plus your remainder, which I'm going to write as r of x. So f of x, which was our original function, and our original function was 6x cubed minus 19x squared plus 16x minus 4. So that's going to equal my divisor, which was the x minus 3 times my quotient, which was 6x squared minus x plus 13 plus my remainder, which was 35 divided by x minus 3. So if you multiply these two things together and take that quantity and add this, you will get this right here. For example 2, we're going to divide x cubed minus 1 by x minus 1. So when we set this up, we're going to put our x minus 1 outside, and then we're going to go x cubed. Now the thing with doing long division, if you're missing terms, you need to replace them with 0. So I'm going to go plus 0x squared plus 0x minus 1. You need to have the placeholders there. And now I'm going to start the whole process. So I'm going to see how many times this x goes into x cubed. So x times x squared will give you x cubed. Now typically, if you notice too, I'll put my x squared terms above my x squareds, my x's above x's, and so on. So now I have x times x squared will give me x cubed. Then I'm going to go negative 1 times x squared will give me a negative x squared. I'm going to hug it with parentheses, slap a negative on it, and then distribute that negative here and here and change that to addition. So now I have x cubed minus x cubed, which is 0. 0x squared plus x squared will give me x squared. We're going to pull this, so I have plus 0x. And we're going to start the process all over again. So x times what gives me x squared? And that would be x, so I have plus x. X times x will give me x squared. Negative 1 times x will give me a negative x. So now we're going to hug it with parentheses, slap a negative, distribute that negative, change this to addition. My x squared terms are going to cancel. I'm left with x, and I now need to pull down that negative 1. And if you notice, you have an x minus 1 here and an x minus 1 here, which is going to tell us that we need to add 1. So I end up with my x and my minus 1. When you hug it with parentheses, slap your negative on it, and distribute it, you will end up with 0. So your solution or quotient is x squared plus x plus 1, and you have a remainder of 0, so you are done at this point. Now for one a little bit more complicated, we want to divide 2x to the fourth plus 4x cubed minus 5x squared plus 3x minus 2 by x squared plus 2x minus 3. So the first thing I'm going to do is rewrite this. So we have x squared plus 2x minus 3, and we're going to divide 2x to the fourth plus 4x cubed minus 5x squared plus 3x minus 2 by that stuff. So, same process. We're going to see how many times x squared goes into 2x to the fourth. And we're going to have to multiply x squared by 2x squared. So 2x squared. So x squared times 2x squared will give me 2x to the fourth. Now I'm going to take 2x and multiply it by 2x squared, which will give me plus 4x cubed. And then I have minus 3 times 2x squared, which will give me negative 6x squared. Same process. Hug it with parentheses, slap a negative on it, distribute the negative. Change it to addition. X to the fourth terms are going to cancel. Actually, in this case, my x cubed terms are going to cancel because a positive 4x cubed plus a negative 4x cubed is going to cancel. Then I'm left with negative 5x squared plus 6x squared, which is a positive x squared. I have to bring down my next term, which is a plus 3x. And x squared goes into x squared one time. So I'm going to go plus 1. And x squared times 1 will give me x squared. 2x times 1 will give me plus 2x. And negative 3 times negative 2 is a positive 6. So we're going to hug it with parentheses, slap a negative on it, distribute that negative, change it to addition. X squareds are going to cancel. 3x plus a negative 2x is x. And I have a negative 6 plus a negative 2, which is going to give me minus 8. So this here would be my remainder. So I'm going to come up to the top and go plus x minus 8 divided by x squared plus 2x minus 3. Now another form of division that we can use if we have a factor or we're dividing by something such as x minus k that looks like this. So this would be like an x minus 3, x plus 2, something like that. If we're dividing by something that looks like that, then we can use what we call synthetic division. Now with synthetic division, what we're going to do is we're going to set this factor right here equal to 0 and solve for x. And whatever you get for that x value, which in this case is k, we're going to pull out up front. You are going to write your coefficients right here. We're going to kind of do this little L-shaped bracket, which is your division or synthetic division symbol. And then we're going to bring our first term down, and then we're going to go k times a, bring that product up here. Then we're going to add, bring that answer down here, multiply k times this, put it up here, add these two terms, bring it down, and so on until we get down to our remainder. So if we look at example 4, we're going to use synthetic division to divide x to the fourth minus 10x squared minus 2x plus 4 by x plus 3. So because x plus 3 is a first degree or a linear function, we can use synthetic. So I'm going to go x plus 3 equals 0. So that tells me x is equal to a negative 3. So I'm going to write a negative 3 out here. I'm going to put my coefficients. So I have 1x to the 4th. I have no x cubes, but I do have a negative 10x squared, a negative 2x, and a positive 4. You will always bring your first term down. So I have 1. Negative 3 times 1 is a negative 3. So I bring that up here. 0 plus a negative 3 is a negative 3. Then I have negative 3 times negative 3, which is a positive 9. Negative 10 plus 9 will give us a negative 1. Negative 3 times a negative 1 will give me a positive 3. Negative 2 plus 3 is 1. Negative 3 times 1 is a negative 3. Add these together and I get a positive 1. Now if you're left with anything other than 0 here at the end, that is your remainder. Then you have your constant, your x term, your x squared, and then your x cubed. So your final answer would be x cubed minus 3x squared minus x plus 1 plus 1 divided by the quantity of x plus 3. And this is how you do synthetic division. Now we do have two things to look at. One is the remainder theorem, and it says if a polynomial f of x is divided by some factor x minus k, then your remainder is going to be some function f of k. So this really means you're going to take your original function and evaluate it at whatever this value is right here to come up with that remainder. Now we also have the factor theorem that says a polynomial has a factor x minus k if and only if the factor, when evaluated, or when you evaluate the function at that k value, gives you 0. If it does not give you 0, it is not a factor. So you do not want a remainder if it is a factor. So example 5 says use the remainder theorem to evaluate the following at f of a negative 1. And remember, f of a negative 1 is really like saying x equals a negative 1. So if I take my negative 1 out here, and I go to do my synthetic division, I have 4x cubed, 10x squared, negative 3x, and a negative 8. I'm going to pull my 4 down. Negative 1 times 4 is a negative 4. 10 plus a negative 4 is 6. Negative 1 times 6 is a negative 6. Negative 6 plus a negative 3 is a negative 9. Negative 1 times a negative 9 is a positive 9. And negative 8 plus 9 is a positive 1. This is my remainder. So I end up with, if I go remainder constant x, x squared, I now have a solution that is 4x squared plus 6x minus 9 plus 1 divided by x, and that's really x plus 1. So your remainder then is this right here. Now, the key piece here was this 1. Now your remainder theorem, okay, so let's look at that 1, says if I evaluate my function at negative 1, so in other words, if I go and I plug a negative 1 in for this x cubed, this x squared, and this 3, I should end up with this 1 right there. So let's just see. 4 times a negative 1 cubed. Negative 1 cubed is negative 1 times 4 gives me a negative 4. Then I'm going to add that to 10 times a negative 1 squared. Well, a negative 1 squared is a positive 1, so I end up with plus 10. So this is going to give me 6. Minus 3 times a negative 1 will give me plus 3, or 9. And then I have that minus 8, which gives me 1. So these two here are equal, and that's how we use the remainder theorem. And now our last example says, show that x minus 2 and x plus 3 are factors of 2x to the fourth plus 7x cubed minus 4x squared minus 27x minus 18. Now you can use long division. I have no problem with that. Personally, I'm going to use synthetic though. So for the first one, I'm going to set x minus 2 equal to 0, and this is going to give me x equals 2. So if I do synthetic on this, I have 2, 7, negative 4, 27, and a negative 18. I'm going to pull this 2 down. So I have 2. Then I have 2 times 2 is 4. 4 plus 7 is 11. 2 times 11 is 22. 22 minus 4 is going to give me 18. 2 times 18 is 36. And actually this up here is a negative 27. So negative 27 plus 36 is going to give me 9. 2 times 9 is 18, and negative 18 plus 18 is 0. So this is my remainder. My constant is 9. I have my x term, my x squared, and my x cubed. So my answer then will be 2x cubed plus 11x squared plus 18x plus 9. So this here would be a factor with this factor of x minus 2. Or I can now go ahead and do x plus 3 is going to give me a negative 3. And you can do one of two things to prove that this is a factor. You can either do synthetic division on this right here and prove that you get a remainder of 0, or you could do x plus 3, or I'm sorry, do the synthetic division on your new quotient and get 0 as well. And if you get 0, then that just verifies that you have another factor. For the sake of this example, let's just go ahead and continue on. We have the 2, we have the 7, the negative 4, negative 27, and the negative 18. So I'm going to start out by bringing the 2 down. Negative 3 times 2 is a negative 6. 7 plus a negative 6 is 1. 3 times 1 is a negative 3. Negative 4 plus 3 is a negative 7. Negative 3 times a negative 7 is a positive 21. Negative 27 plus 21 will give us a negative 6. Negative 3 times a negative 6 is a positive 18. Negative 18 plus 18 is 0. Remainder, constant, x squared, x cubed. So I'm left with 2x cubed plus x squared minus 7x minus 6. So because I had a remainder of 0, this also confirms that x plus 3 is a factor. And that will conclude our video for tonight. Have a good night, and we'll see you tomorrow.